Hi grade 12s, this is just the second video in the function section. So this is just explaining what the inverse of a function means. So just the word inverse. Inverse, let's talk about numbers here. 3 over 4, the inverse of this would be 4 over 3. So you're swapping, you're flipping it. So now when it comes to a function, we are talking about the swapping not of numbers but of x's and y's. So just make sure you know the notation. So the function itself is f or g or h, and then the inverse is f, g or h to the negative 1. All right. Then, so when we're determining the inverse of a function, we have to look at swapping of x and y. Okay, so that's the key bit here. All right, so if your function is f of x, then you're going to write f dash x for the inverse. Okay, but the first thing you need to do is when you're given f of x, you've got to change it to y equals. Okay, so if it's f of x equals to 2x plus 1, rewrite it. Remember, f of x is talking about a y value in a function where there's x's involved. So the y value is equal to 2x plus 1. So rewrite it with x's and y's. Then where we see an x, we put a y, and where we see a y, put an x. So don't rearrange the equation. So what I mean by rearrange, don't do this. So I don't want to try and get x by itself. So I'm not going to move things over and change their positions. Okay, that's not the idea. The idea here is rather to literally, where you see a y, put an x. Instead of y, write x. So it's instead of y equals 2x plus 1, it's x equals 2y plus 1. So where you see an x, put a y. Where you see a y, put an x. All right. And then you get y by itself. Okay, so the first part is write it in terms of y equals something. Then swap x and y. That's not algebra. It's just a quick swap. And then you do the algebraic rearranging. Okay, to get y by itself in the new system. So that's the new one. Now we need to get y by itself. How do I get y by itself? I can take that 1 across, and it becomes x minus 1. So x minus 1 equals 2y, which is the same as 2y equals x minus 1. And then get y by itself by dividing by 2. Okay, and so in terms of y, our inverse is equal to x minus 1 over 2, and so we rewrite it as the question wanted, f to the negative 1 of x. So your notation. So if we were to work with this example here, so we've got the original y equals 3x squared. So the first step is to replace x and y. Right. Then the next step is to algebraically rearrange to get y by itself. So at the moment it's 3y squared. I need to move the 3 across first, and then I can square root both sides. Okay. So please remember that you are working with, in this case, a y. They just asked you y equals, so your inverse is y equals plus minus the root of x over 3. You need the plus minus, otherwise you're not getting the correct full graph effect. Okay, so then going into a revision of logarithms, logs. We did this in the first section, sequences and series, and we're going to use it quite often to work with different bits in maths where you can't get the same base. So logarithms or logs are designed to help you work out unknown exponents. So in this case, we have if 2 to the power of a equals 8, in basic maths, we could have just written this as 2 to the power of 3, so a is equal to 3. But in your calculator, you can also write it as log 2, 8 equals 3. So you take 2 to the power of a equals 8. So now this is the base of the exponent. It stays the base of the log. So it's log base 2 And then the a needs to be by itself. So we move the a to be by itself. And what are we left with? The 8, we need to put it with the base. So it becomes, the 2 is much smaller. So it's log little 2, 8 equals a. It's like the 2 is dropped down. Right, so then if you type in your calculator log base 2, 8, then you're going to get the answer for a, which will be 3. Okay, so logs are mainly used when we can't get the same base to solve our exponent. So for this one, we need to determine the equation of the inverse for f of x equals 5 to the power of x. So the first thing you need to do is write f of x as a form y equals 5 to the power of x. And then our inverse, straight away, switch x and y. So where I see a y, I put an x. Where I see an x, I put a y. Then we've got to do the algebra. So the first bit, just swapping x and y. Then we got to get y by itself. So in order to get an exponent by itself, we've got to use logs. So what is the base of the exponent? It is 5. So the base of the exponent is 5. So it means the base of my log is 5. In this one, the 5 is with the y. I want to get it away from the y then. Okay, so what is the 5 going to join the x? So then this is the equation of your inverse. So your inverse is going to be f negative 1 of x is equal to log 5x. Okay, and we're going to get on to what a log graph looks like, but for now it's just to get into using the logarithms. Okay, then for example 4, it's just going backwards from the log. So I'm just going to hide that for now. Then we can talk about it. So f of x equals log 5x, so base 5. So we're going to first write it in the form y equals log 5x. Always put it as y equals. That's now your f graph, your original function. Then for your f negative 1 graph, you need to, where you see a y, put an x. Where you see an x, put a y. So just the swap. Then we've got to algebraically rearrange. Now, I need to get y by itself. It's in log, so now I need to get it out of log form. So the first thing to do is, what is the base of your log? It's 5. So that is then the base of your exponent. In the original, or in this first step, the 5 is with the y. So now I want the y by itself. And what is going to join the 5? It's the x. So we're putting it back into exponential form. Right. And so then my f negative 1 graph is equal to 5 to the power of x. Okay, so then you can work on exercise 1, A1 to 6, B1 and 2, C1 and 2, and then that's just practicing moving out of log form into exponential, doing the swap, doing the inverse, just writing out the equation. Then in the next video we talk about the graphs that come with this inverse. All right, so that is it. Enjoy.